So thank you, Mr. Chairman. So ladies and gentlemen, let me say at first that for me it's a great pleasure to be here today and to give this presentation. And I would like to thank Professor Dimkic for giving me such a great opportunity. And I would also like to express my personal happiness that this center is approved because I was involved since very early stage. So the title of my presentation is, Can we detect the impact of climate change on flood regimes? We have been talking about climate change since this morning. And this is obvious that climate change is affecting our culture, our society, our environment, and consequently water regimes. But it's not climate change alone. As it was said many times, it's a mixture of global change drivers. And it is very difficult to distinguish and to say how much climate change is really affected water resources. That's the reason that I have chosen to present one case study where a lot of scientific tools are used to show can we really detect and how can we detect the impact of climate change on floods. So the study area is in France, on the west part of the city of Lyon, in the catchment of Yzeron river basin. And objective of the study is, as I said, to detect the climate change impact on floods, because this is the area where river Yzeron flooded very often, sometimes twice a year. So I will present the methodology and the results and of course the conclusion if we really succeeded to distinguish this impact. So this is a flood event in Yzeron basin, just how that looks. And this is the study area. This is a catchment on 160 square kilometers, which is basically upstream surrounded with a mountain and downstream is a plain. But I would like to emphasize that it is a peri-urban catchment. It means that in hydrological behavior, there are mixture of urban and rural behavior. So, and there are also peri-urban areas which are around the city of Lyon, so there is a very fast urbanization. So that indicates that urbanization is one of the very important global change drivers which has to be examined also before we give answer is that the climate change will affect floods. So this is just the measurements which are available for this study and instrumentation. So upstream the basin is a rural area with a very long discharge data. Downstream, urban area with discharge data, but only for 10 years from 70s. And of course, precipitation data given by Met of France everywhere, different time step from 6 minutes to 1 hour. So this is increase in flood frequency. Anyway, from the available data, diachronic approach is used, 70s and 90s. So it is seen that in 90s, discharge dramatically increased. So the question is that climate change which increased, or it is a very rapid urbanization which increased this flood? So we try to answer this question. So as a data, we had urbanization in 2 periods from aerial photographs, 1979 and 1966, where we can see that from red points in 90s, downstream part was extremely urbanized, and upstream part stayed mostly rural. So this is just the land use change in the percentage, where one can see that there is increase of some urban areas and urban areas, which indicates that we have now to answer and to develop methodology how we will detect just the part of urbanization on flood regimes. So, but also one can see from very long series of rainfalls and from the frequency analysis that in the 90s, comparing to 20s, 40s, there is increase in rainfalls. So it's very difficult to distinguish again. Rainfalls are increasing, urbanization is increasing, so who is really responsible for this flood? So this is just, again, a compared daily rainfall distribution about the rainfalls. So this is the methodology and looks maybe complicated. So I will just extract the impact of urbanization, which was examined at the first. So the idea is that make a virtual series with the land use change from 90s and make a virtual series with the land use from 70s, having the hypothesis that rainfalls was the same. So from these results, we can conclude if the rainfalls was the same, it means that there is urbanization which was responsible just for this part of increase in flood frequency. So this is a drainage. Of course, to do this analysis and to construct virtual series, we use semi-distributed hydrological model, rainfall runoff. But before that, the catchment was divided in 30 sub-catchments, having 3 criteria. One criterion was land use change and occupation. The other criterion was topography. And the third criterion that we cannot have more than 30 sub-basins. So we created 2 simulators, simulator 70s and simulator 90s, and one can see that from the subcatchments in the 90s, there are more red subcatchments. It means that there are more urbanized subcatchments, and they will have different response than the rural part. Blue are peri-urban, so they have mixture of both hydrological behavior. So we have 2 simulators, and now, using a hydrological model, we can have virtual series for 70s and 90s. So this is just result of the calibration for different seasons, because of course the result depend from seasons. And I would like to say that for the sampling method was used this peak over threshold method, which is a method which picks all the events which which go over a certain threshold. It means low duration we take, higher rainfalls we pick, or higher duration we take, low rainfalls they pick. That was decided because of the statistical comparisons of this virtual series, because we need at the end to have statistical comparisons and to express our results in a statistical values. So, first of all, statistically, the model validation was examined, and there the zero hypothesis for the Wilcoxon-Mann-Whitney test was that 2 series belong to the same population. So if the answer is yes, it means that model is good for different durations. If the answer is no, model was not good, but we can see that basically from the statistical point of view, this model was good and the simulation was okay. Now we are coming after validation of the model to the results of impact of urbanization on this runoff, having the hypothesis from the beginning that rainfall was the same. So, where is the difference when we compare 70s and 90s? Again, the hypothesis is that 2 series belong to the same population. So, the difference is only where the answer is no. And one can see that the answer is no only for duration of 1 hour and 3 hours. It means that only for the runoff with the return period less than 2 years, 90s, runoff in 90s is higher than runoff in 70s. So the answer is that urbanization affects flood regime, but only for a very little floods. It means floods with a return period to 2 years. So now, knowing what is the impact of urbanization, we can go to the part of rainfalls. And this is peak over threshold distribution for observed runoff, where we just confirm the result that 90s are over 70s only for little floods. But of course, if we go to 1 day to longer values, we can see that 60s overpass floods of 90s, but not for a very big floods, with the big floods which overpass 10 years period. If we make the same distribution for rainfalls, we can see the opposite results. for the values of 1 daytime step and 6 daytime step, 60s are below 90s. So it's completely on the opposite than it was for the rainfalls. But for the bigger floods, it's the same. Definitely for the bigger floods, which have return period bigger than 10 years, 90s is above 70s. So it means the same behavior with rainfall statistical test like for the runoff. So the conclusion is, this is the difference, statistical comparison between 70s and 90s with 2 different intervals, and this is somehow the conclusion at the whole basin level. It means for the little floods, which are below return period of 2 years, is urbanization which is responsible for increasing flood frequency. But for the bigger floods, from 10 years on, it's definitely also rainfall which is taking part in rainfall. It means climate change impact which is taking part in increase in flood frequency. And of course, if we go for extremely big floods, like 50 or 100 return period, this is both climate change and urbanization. It means the global change drivers which affects flood regime. And this is just the projection. If we go with urbanization 24% or 33 in 2025, of course, more we urbanize, it's obvious that it's impact of urbanization. But the climate change and the rainfalls, they have one important impact on flood regimes from 10 years return period. It means for bigger floods. And this is the conclusion which I just said. So I would conclude that semi-distributed hydrological models, peak over threshold method as a sampling method, also what was used, statistical test, can be used together to detect the impact of climate change on flood regimes. So thank you for your attention.